Welcome to qnawire.
In the textbook, we can see the depiction of a compound with p orbitals to display the delocalization of a radical across numerous carbons, as opposed to just one. But as an organic chemist, it is hard to explain such processes without drawing the resonance forms. So let's draw the resonance forms. So carbon, double bonded to another carbon, that is single bonded to another carbon. The radical is associated or drawn out on this carbon. Okay, and let's draw out the corresponding hydrogens. CH, CH. Okay, so the benefit of having a double bond adjacent to a carbon with a radical on it is that that radical can be delocalized across numerous carbons as opposed to just fixed on one, and I'll explain that using resonance forms. So, using a fishhook arrows are just singular-headed arrows that show the movement of one electron as opposed to two, which we usually depict with double-headed arrows. So moving this electron with a fishhook arrow and moving a singular electron from this double bond onto this single bond, we can create a double bond. Okay, but we can't usually just show the flow of one singular electron stemming from a double bond, so we have to show the movement of the other electron. So the other electron is moving onto this carbon right here. Okay, and the product of this, or the resonance form, is a carbon with a radical on it. We moved the double bond from this position onto this position, and that we did that using the fishhook arrows, and then we should get our compound. So rather than having the radical associated with only this carbon, it is now associated across all three carbons, because we can move the radical from this position. I'll do it in green so it's a little neater. We can move the radical from this position onto this position, and then the corresponding radical will go onto this carbon right here. Okay, so it's associated with all three carbons rather than just focused or localized on one.